In this example, we have a particular type of bacteria that follows a continuous growth model. So I'm going to go ahead and underline some things that are going to be important for us. This is continuous growth. If the initial bacteria count is 114, so our initial value is 114, and it's growing at a rate of 2.25% per hour, how many bacteria will there be after 2 weeks? Okay. What we can do is just set up our growth model, and this one though is continuous. So when you see the word continuous growth, we need to use P times E raised to the T power. So PERT, just like the shampoo. If we fill in the stuff that we know that the initial population is 114. E is just E. That's a constant, and it will remain as E. The rate is 2.25% or 0.0225%. This is a spot where some students tend to make mistakes. So why don't you go ahead and just double check and move that decimal 2 to the right, and we should get 2.25, and that should be exactly the same as our percent rate. That is per hour. We need to know how many bacteria will there be left after 2 weeks. These units need to agree, and right now they don't. So we can't really change this rate right now. It's just per hour, but we can change 2 weeks into hours. If we do that, we need to multiply 2 times 7. That'll be 7 days, and if you use your unit conversions, we can do this with fractions. And then we also need to take, now the weeks are gone, now we're in days, and now we need to say how many hours there are. So there's 24 hours in 1 day. And you can see then we're going to be left with hours. So if we go ahead and type that into the calculator, we've got 2 times 7 times 24, and that would give us 336. So this is 336 hours. That is what goes in for the time. The time would be 336. So next, all we need to do is just type this into our calculator, 114 E, and then we're going to raise that to the 0.0225 times 336. Show you how that looks in the calculator. And we're going to go ahead and hit enter here. And we've got our value, 218,862.3885. Well, we can't really have a fraction or a decimal of a bacteria, so we're going to round to the nearest whole number here, and that would be 218,862, and that's the number of bacteria. So you're seeing now that hopefully that even at a relatively low rate, 2.25%, it's per hour, and just in 2 weeks, we go from 114 to 218,862. A tremendous increase, and this is the power of compounding at work.